Ciao friends and welcome to a new video from SQL BI. In this video, I want to show you how to work with a model and compute correct totals and percentages even in the presence of security. Now, how comes that security is a problem for percentages? Picture this. If you compute the percentage of a continent against the entire world, and you are looking at Europe, Australia, North America, then the percentage of Europe is something like 20% if you divide it by the total of the entire world. But as soon as you secure the model, let's say that you create a role that is able to only see Europe, then when you compute the percentage, you can only see Europe at the row level, but at the total, you still see Europe. Therefore, the total goes to 100%. Now, this might be correct. This might be exactly what you want to see because a secure model can only show data that is visible to the user. But sometimes you might be interested in showing the percentage of Europe against the entire world, even though you cannot see the sales in individual continents or countries which are not visible to the user. If that is the case, you need to change slightly the model, create an unsecure table, and then use that table specifically for your calculation. Besides, sometimes security is placed on a dimension, let's say customer, and you want the user not to be able to see any detail of customers he is not allowed to see, but at the same time you want it to be able to slice by some attributes, like for example the gender. And again, if that is the case, you need to change a bit the model in order to obtain your goal. Anyway, as usual, it's much better to look at numbers with Power BI than explain everything by words. So let's jump to the demo and let's see the example in practice. I have our usual Contoso model, and I already created a matrix that is slicing by continent, Australia, Europe, and North America, and I see the sales amount and the percentage overall. Now, percentage overall is a rather simple measure that just computes the division of the sales amount divided by the sales amount for all the customers. Therefore, it just computes a correct percentage. And you can see the number, let me place it a bit lower here. The percentage 682, 2890, and 64.28 account for 100%. Now on this model, I created some roles, and specifically I created 3 roles, one for each continent. If we look at the roles that I created, I have created 3 roles, Australia, Europe, and North America. And if we look at Australia, it places a row filter over the customer table so that it shows only the customers whose continent is Australia. And the same for Europe, that shows only Europe, and the same for North America, that only shows North America. Now, what happens if I look at my model acting like one of these users? Now, the thing is, if I browse the model using View As and I say, I want to see the data as a user that is only allowed to see Europe and nothing else. As soon as I click on OK, look at the numbers, Europe now shows 100%. And the reason is all here does not return all the customers. It only returns the customers that are visible to the specific users given the security conditions. There are no ways in DAX you can overcome the security conditions. Once rows are made invisible by security, they will never be visible. Now, this might be correct because you might browse the model, for example, not here, for example, by looking at Australia and Europe, and the percentage that you see at this point accounts for 100%, and 19% is 19% of the grand total, 4 millions. So if this is what you want to obtain, then you can stop watching the video because you are already all set. But sometimes you want to show a different number. When I don't have any filter, I can easily see that Europe accounts for 28.90%. And I might want to show the same number, 28.90%, even though I place a security that does not let me see North America or Australia. Beware that showing this number is actually disclosing information. You're not showing the details of sales to individual customers in the countries which are not visible, but still you're showing a total, and from the total a user might deduct further information. Anyway, we are not interested right now in the amount of information that you are disclosing. If this is your goal, then you need to make sure that you have access to the total, even though you cannot see the individual rows. And there seems to be no way to do that, because as soon as I place a filter over the customer table, then I will no longer be able to see sales in North America, and I will not be able to aggregate sales in North America. However, I can compute the totals in a table that is computed before security is applied. And if that happens, that table will be visible to all the users for the totals only. Let me show you this in a very simple way. If I just create a table, not from here, but from here, and I just call it all sales amount, when I create a row, all sales amount, that just computes sales amount. Now, this is a calculated table. And if I hit on enter and I look at the result, it shows 12 millions, the grand total of all sales. Now, even though I can browse the model and look at the model, viewing it as if I were a different user, let's say Australia and Europe, or just Australia, when I click on OK, even though I'm viewing as Australia, I can see just all sales amount, the grand total, because the number has been computed before. And if I place all sales amount, okay, from here in my matrix, you see that I see 12 millions, even though the total of sales amount is only 841,000. So I created a table. The table is being computed before security is applied, and the values which are stored there are visible to everybody, unless I place a further filter on the table, which is not what I want to do. Using this technique, I can create a calculated table that contains the totals at the granularity that I want to disclose, and then use that table in order to compute my totals. Now, the table that I have in mind does not contain the details of the customers, but still I will want my table to be sliced by other tables. Namely, in my model, I have the store, I have the dates, and I have somewhere the product. So I want to create a table that can be sliced by product, by date, by store, but it cannot be sliced by customer. At the customer level, it will only have the continent and nothing more. So if I want to compute my table, or not even the continent, let's see what I create. Let's go to modeling and let's create this table. As I said, we need to define the granularity. So let's call the table sales no customer, because it's a table that does not contain information about the customer, and I just summarize sales, and I summarize it by all the keys that I want. So I want the sales, no, I want product key, I want store key, and before that I also want the date. Now, the table as created this way does not contain the sales amount, but the granularity is the desired one, because I have the product key, the date, and the store. No, this way, okay? I have product key, date, and store that will be useful to build the relationship. I just need to add now the sales amount. So add columns around everything. And then I just create a new column, total sales, that contains the sales amount. Now my table contains the keys, the relevant keys, okay, and the amount of total sales. I need to build the set of relationships. So let's do that in a new layout where I place sales no customer and then the relevant tables. Customer is not interesting. I want date, I want product, and I want store. And then I create the relationship between product key and product key, and then between store key and a store key and store key, and finally between date and date. Now I have my sales no customer, and I can create a new measure. Let's call it sales not secured with a much larger font. That just computes the sum of sales no customer, total sales. And then we just place it here. I compute my, where is sales not secured, place it here. You see it shows the same value, 12 millions. I can now get rid of my old sales amount. And I can also format this measure as a decimal number like all the other ones. Now, sales not secured computes the total for Australia, not the total for Australia. It's not sensitive to the country, but if instead of slicing, or the continent, but if instead of slicing by country, for example, I slice by brand, then you see that sales not secured shows a value that includes the sales of a datum for the entire world. And now I can use my sales not secured measure in order to compute my percentage. I have percentage over all. Let me copy the percentage over all, and we create a new measure. And let's call it percentage not secured. That instead of computing the sales amount for all the customers, it just can call the measure sales not secured. So it divides the sales amount, which is sliced by all the attributes, by the sales not secure, which is sliced by all the attributes except for the customer. And when I place it in my report, let's get rid of sales not secured. Percentage not secured, here it is. I need to format it as a percentage. And instead of slicing by brand, let me slice again by continent. I slice by continent, that makes it more readable. You see that Australia only shows 6.82%, even though the percentage overall shows 100%. Be mindful, both numbers have a value, so you need basically to choose which one to show, or both if you need them. And if I browse the model, not just as Australia, but using different roles, so let's say that I look at Australia and Europe at the same time. Now, please look at Europe, it's 28.90% right now. And if I browse like Australia and Europe, the percentage overall shows 80%. Percentage not secured still shows the correct value, 28.90%. Again, I know I'm repeating myself. It's not the correct value. It's one value that might be useful for your reports. So far, we have seen that if you need to show values which are secure, which are invisible due to security, you can create a calculated table that contains not secure data and use it for your own calculations. But sometimes the requirement is a bit more subtle. You don't want to hide all the attributes of the customer. You don't want to hide entirely all the attributes. You want to be able to slice, for example, by customer gender, or by customer continent, or by customer country. Right now, my sales not secured is not sensitive to any attribute of the customer table. Let me show you by getting rid of percentage not secured. I just show sales amount and sales not secured. You see that I'm slicing by continent, and sales not secured is not slicing anything. It is slicing by any attribute of the product, any attribute of the data, but anything that I place from the customer table will not slice my total. And maybe I want to slice it by gender, or I want to slice it by country. I want to do some slicing, but not all of them. I want to hide, for example, the individual customers, the address, and some sensitive information that I don't want to show. If that is the case, then we need to change the model a bit. we need to create a new table, and this table will be linked. Now let's stop viewing. Will be linked to sales no customers, but it will only contain the attributes that we want to use to slice sales no customer. In order to do all the job, we need to first create the table containing those attributes. And this is not hard to do. Let me do that first with DAX Studio. Okay. The table is basically a copy of my sales no customer. No, actually no, it's a different table. So let's go by evaluate. Let me see the code that I wrote. So I use the same as the article. We use summarize, and we summarize customers this time by the attributes that I want to make visible. And let's say that I'm interested in customer continent, in customer country, I want the customer state, and then the customer gender. I run it, and the result contains continent, country, state, and gender. Now, the table as it is missing a key. And if I want to build a relationship with this table, I need to add a number, some number that let me create the relationship with the remaining part of the model, namely with sales no customer. So in order to build the key, we store this in a variable, and then we return add columns to my variable, and then we need a column name. I call it customer attributes key, which is just the row number over my table. And if I run it, now you cannot appreciate the number, but if I sort it by the column order by, you see that it returns a number 1, 2, 3, 4, 5, which is nothing but a uniquely increasing number that can be used as the key. Now that I have my code a bit smaller, I can copy everything and create my table. So let me go here, and we create a new table that I call customer attributes, and the same expression that I used before. Now I have continent, country, state, gender, and customer attribute key. The next step is that I want the customer attribute key to appear in my sales no customer table. And because sales no customer table has been generated starting from sales, because we summarize sales, we need to add the customer attribute key to the sales table. So we need to create a new calculated column in sales, and we call it customer attribute key. We can just use lookup value out of customer attributes. We want the key where customer attributes continent is the same as related customer continent, because I'm in sales, so I cannot access column in continent unless I use in customer unless I use related. Then I need the country, which is again related customer country. Then I need the state, which is the related customer state. And finally the gender, that is again related customer gender. If I did everything correctly, that creates a calculated column in sales that contains the customer attribute key. And as you see, we have no blanks anywhere. Because of the way we created the table, starting from customer and looking from customers, the relationship is for sure valid. Now we have the customer attribute key. Let me copy this name And we can go in customer no attributes and add it as one of the many columns. Not here, in sales no customer. Where is it? At the bottom, of course. We group by product, date, store, and we also add the customer attribute key. That is sales customer attribute key. By hitting enter, I now have a new column in my table that is the customer attribute key. I changed the granularity of the table, increasing it by adding one column. Now that I have the column, I can create the relationship. So I can place my customer attributes table here. Go away, please. And I can create the relationship between customer attribute key and customer attribute key. Now, any column from customer attribute will slice my sales no customer table. Let's take a look at the report. If I slice by continent, of course, nothing changes. But if instead of slicing by customer continent, I slice by customer attribute continent, and I add it on the rows, you see that the customer attributes continent slices sales not secured. It doesn't slice sales amount because I missed the relationship. I created my customer attribute table, but I also need to make it slice sales. Otherwise, the totals are not fine. Here is my table. Let me bring it in the right place. And then I need to create actually a relationship between customer attribute key and customer attribute key. So that now in my report, I see the sales amount, the percentage overall, and the sales not secured. This report will show the same values as long as I slice by the same column. So only columns which are in customer attributes. Therefore, in customer attributes, I will not be able to see all the attributes of a customer. I will not be able to see sales by individual customers, but the total level will be visible. And now that I have my sales not secure table, what if I want to compute, for example, the percentage of the sales amount against all the customers with the same gender? I could not do the same with the previous model because gender was not filtering in any way my sales not secure table. But now gender is filtering, so I can get rid of continent, for example, add gender, and you see that gender is filtering sales not secured. And this is happening with the model when it is not secured, but the same is happening if I view it as Australia and Europe. Look at the totals, they are not going to change because the sales amount changes because sales amount is only seeing the values of Australia and Europe, but the total is still showing the total of all the world. And I can use this number in order to compute my values. So I can compute my percentage of customers with the same gender. Again, let me see the name that I chose. PCT same gender. I can create a new measure. PCT same gender. Where I divide the sales amount. And then I use calculate to compute the sum of sales and no customers total sales. I get rid of any filter from the customer attribute table, customer attributes table, and I restore the values of the gender, customer attributes gender. In case you are wondering, I could have used all except instead of all values, but there is a subtle difference between all except and all values, and I strongly prefer to use all values all the time. There is an interesting article about the topic, and I guess it will be linked in the article. Now, PCT same gender computes the total of the customers with the current gender against the customer with the same gender over the entire world. And I can look at the total female, male, let's slice by continent, for example, before, and then expand it further and show PCT same gender as a percentage here. Now you see that it shows 6044 and then 717, 3009, 2718. The numbers are not additive. That is totally expected because I'm computing the percentage of female in Europe against the percentage of all female over the entire world. The numbers are expected not to be additive because I'm computing the values based on numbers that I simply do not see on the screen. Typically, users will not see sales not secured in their report. They just need to trust that these numbers are actually correct. And you can do the same this way, or you can just change it, and this produces a slightly different value. Now the numbers seem to be additive because you see that 644 and 3009 account for 36.53%. So it looks like these numbers are more correct. They are not. Both the previous numbers and these numbers, they are all correct. They are just a bit harder to read. Besides, non-additivity is visible at the total level. You see, 36.53%, 34.98%, but the total shows 35.72%, which is not the sum of individual rows. And again, that is totally expected because I'm showing here the percentage of Australia and Europe against the percentage of all the customers. The filter on the gender is no longer present. So whenever you are using these techniques, you're using what we call non-visual totals. Non-visual totals are totals which are based not on what the user sees or because of security, but on totals that are computed before security is applied. It's a very powerful technique, and when you need it, it's the right way to go. Of course, because totals are harder to read, you need to educate your users the proper way. As you have seen, whenever you have security restricts the visibility of data. Functions like all selected, all except, all the functions that extend the filter context, they will not let you see data that is secured. And that is for the best, because you do not want to disclose data that security prevents you from seeing. If you need to be able to see the totals, then you can overcome the limitation by creating a specific table which is not subject to security. In this table, you place the totals at the granularity you desire. The granularity can be the total without some of the dimension, namely the secured dimensions, or it might be all the dimensions which are not secured plus some of the attributes of the dimension that is secured. The choice is up to you. You need to make a choice discussing with users and understanding exactly the kind of totals you want to see. And at the end, by playing with these new tables, you can create non-visual totals, non-visual percentages, and compute correct percentages. Be mindful that as soon as you use non-visual calculations, it's absolutely normal that the totals do not sum up. You see values row by row, and the total will be a different value. That is totally correct. It is expected, it is correct, but it requires some getting used to, because users will probably look at the numbers claiming that it is wrong. So it's your task as a DAX developer to explain the meaning of these numbers so that they can be read the right way. Enjoy DAX!